Okay, so today we are going to learn about what's called the distance and midpoint formulas. But before we do, we're going to do a little square root warm up because you're going to need to be able to simplify square roots when we use the distance and midpoint formulas. So let's jump right in. I'm going to start by going through a couple problems with you. Let's refresh our memories on how to simplify the square root of 50. So before we get into the square root of 50, let's even remember, go back a step further. For example, the square root of 9 is 3 because 3 times 3 equals 9, right? So we can only take we can only take square roots of numbers that are perfect squares. Like 9's a perfect square, 16's a perfect square, 49 is a perfect square, so the square root of 49 is 7, right? Well, 50 is not a perfect square, so we need to make 50 into a perfect square. Well, how can we factor 50? We can make 50 into 5 times 10, and you could have started any other way. You could have done 2 times 25, whatever you want. But ultimately, 10 is 2 times 5, and this tells me that 50 is really 2 times 5 times 5. No matter how I started factoring 50, I'm going to get to the same thing here. So, okay, 2 times 5 times 5, let me find the perfect square in there. 5 times 5 is 25, right? And the square root of 25 is just 5. So the square root of 25 becomes 5, but I can't take the square root of 2. So simplified completely, the square root of 50 simplifies to 5 times the square root of 2. Now, what if, like in number 2, you have negative 2 times the square root of 54? So you already have like something out multiplied by the square root. It still works the same way. We're still going to simplify the square root of 54, but then we're going to multiply our answer at the end by negative 2. So let me start by factoring 54. So 54, I'm just going to divide by 2. 54 is 2 times 27. And then 2 can't be factored anymore, but I'll make 27, I'll make 27 into 9 times 3. And then 9 can be 3 times 3. So what does this tell me? It tells me that the square root of 54 is really the square root of 2 times 3 times 3 times 3. And again, remember, I'm looking for that perfect square. So this is really 2 times 3 times 9. And then the square root of 9, I can take the square root of 9, but I can't take the square root of 2 or the square root of 3. The square root of 9 is 3. And then the 2 and the 3, I can't take the square root of them. Like I said, they stay under the square root. So, but then they get multiplied. 2 times 3 ends up being 6. So this ends up being 3 root 6. But let's not forget, the whole thing from the beginning was multiplied by negative 2. So now I got to multiply by negative 2. So my final answer would be negative 6 root 6. Okay. Now, you're going to try 2 example problems here. So get out a piece of paper if you don't have one already, and you're going to try these 2 examples. All right, now that we've gone through like simplifying square roots, let's talk about the distance and the midpoint formula. So if I have 2 points, for example, this point here and this point here, these are the points negative 7, 3 and negative 2, 3, right? And if I were to say find the distance between those 2 points, I could just count from one to the other, 1, 2, 3, 4, 5. So those points are 5 units away from each other, so the distance between them is 5 units, right? But that's because they're kind of on that straight line. Now, what if my points are here and let's say over here. The distance between any 2 points is a straight line. But how do I count? Like, how many units over, how many boxes over do I go along this straight line? It's really hard to tell. I can't, because the line is like diagonal, so I can't exactly tell. So an easy way to find this distance would be to plug into the distance formula. And you're going to notice in the distance formula, we have like x2, x1, y2, y1, and they come from the 2 points. We're going to call the x and y from point 1, x1, y1, and the x and y from point 2, x2, y2. Let's jump into an example. So we're going to find the distance between -1, 4 and -1, 10. I'll call this point 1, so this is going to be x1 and y1. And then I'll call this point 2, so this will be x2 and y2, okay? And I'm also going to plot these points. So -1, 4, this will be point 1, and -1, 10 will be point 2, all right? So that's, keep in mind, like we're trying to find the distance between these 2 points, right? That's what we're trying to find. Let me first use this distance formula. If I plug in, it's d equals the square root, d stands for distance. The square root of x2 was -1 minus x1, but x1 is a negative, so now I have like minus a negative squared plus y2, which is 10, minus y1, which was 4 squared. Now I got to do some simplifying. -1 minus a negative. This minus a negative actually turns into a plus, right? So now I have -1 plus 1, which is actually 0. And then 10 minus 4, that's a 6. So 0 squared is just 0. 6 squared, you can use your calculator, that's 36. Now I got to add and then take the square root. Well, 36 is a perfect square, so the distance is 6. Now look, if I went from point 1 to point 2, count up 1, 2, 3, 4, 5, exactly 6 blocks. So that's kind of a confirmation that the distance between those 2 blocks is 6 units. But what if, like we said before, these 2 points, 3, -1, we'll call that point 1, and -4, -6, we'll call that point 2. They're on like a diagonal. I can't count the blocks. So now I got to use the distance formula. Again, let me call my points point 1 and point 2, and it doesn't matter which is which. It doesn't matter. I'm going to just plug into my formula. So x2 is -4 minus x1, which is 3. y2 is -6, and y1 is -1. Remember, though, it's a minus -1. Right? So just like I did before, I'm just going to simplify. I got to do in the parentheses first. -4 minus 3 is -7. -6 minus a -1, that turns into a positive. So this is -5. And remember, when I square a number, I multiply it by itself. So -7 times -7 is actually positive 49. And -5 times -5, again, is positive 25. So now I have 49 plus 25, which is 74. So the distance between those 2 points is the square root of 74. But here's the problem. Now I got to simplify. So the square root of 74, just like we did in the warm-up, what goes into 74? 74 could be 37, 37 and 2. Nothing else goes into 2. But guess what? Nothing else goes into 37 either. So I'm going to leave it as the square root of 74. And I couldn't even type in the square root of 74 into my calculator to get an approximation. This is about 8.6 units. And if I kind of eyeball this distance here, right? Remember this like straight line that I drew between those 2 points? It looks like they're about like 8.6 like blocks apart. Okay, I'm going to pause here. You're going to try this one. All right, now that we've tried a couple finding the distance between 2 points, let's move on to the midpoint. So the midpoint, let me kind of draw what this looks like. Again, I'm going to call this point 1 and point 2. Let me make that look nice. So point 1 and point 2. So if I plot point 1 and point 2, negative 1 comma 4, there's 1. Point 2 is up here. This formula is going to find the midpoint. So instead of finding the distance between the two, it's like, oh, well, I want a point that's exactly in the middle. You might be able to kind of eyeball it in this instance, but let's use the formula. So you're going to notice the formula starts with like a big parenthesis and there's a comma in the middle because you're literally finding a point. It'll be, your answer will be in the form of like x comma y. It'll be the coordinates of a point. All right, so let's plug into the formula. x1, negative 1, plus x2, which is negative 1 as well, divided by 2. And then we have y1, which is 4, plus y2, which is 10, divided by 2. So now I plugged in my x's and my y's. Now I just have to simplify. Negative 1 plus negative 1 is negative 2. And 4 plus 10 is 14, right? And now let's reduce these fractions. So this ends up being the point, negative 1 comma 7. So what I'm telling you is that the midpoint between the two initial points is the point negative 1 comma 7. Where's negative 1 comma 7? Negative 1 comma 7 is right there. And it looks like this green point is midway between the other two red points. Look, it's 1, 2, 3 units from there and 1, 2, 3 units from there. So that's my midpoint formula. Now, sometimes like in this problem, I maybe didn't need to use the formula. I probably could have eyeballed it. But again, just like with distance, we can't always do that. Look at these 2 points here. 2 comma negative 2. That's point 1. And 5 comma negative 6. Where's that? All right, point 2. What's the midpoint? It looks like it might be like somewhere right here. But I don't know. I don't know. You know, it might be a decimal. I can't find it exactly. It's not as easy as the last one. So let's use this midpoint formula. I'm going to call this point 1, so x1, y1, and point 2, x2, y2. And I'm going to plug into the formula. So to find the midpoint, remember it's going to be parentheses. It's like an x comma y. So x1 is 2, x2 is 5, and then y1, negative 2 plus negative 6. Okay, now I just have some simplifying to do. 2 plus 5 is 7. Negative 2 minus 6, that's going to be negative 8, right? Now, 7 over 2, it doesn't go in even, and that's okay. I could either leave it as 7 over 2, or let me make it like a little more like easier to understand. Let me put that into a decimal. 7 divided by 2 is 3.5, and then negative 8 over 2 is negative 4. So what I'm telling you is the midpoint is the point 3.5 comma negative 4. Well, if I go over 1, 2, 3 and a half, here's like 3.5, right? And then -4, go down 1, 2, 3, 4. Oh my gosh, that's right on that green, or that where I had initially written that red dot. So when I eyeballed it, like my eyeballing, it was like pretty good, but I couldn't really tell what the exact coordinates were until I kind of plugged into this formula. So that is all we have for you today on distance and midpoint formulas. Thank you for watching.